have been gone for a week, so I want to make sure that we review concepts of sound. We just, at least you should have, completed this worksheet, which was on the harmonic simulation. So pull this out, I'm going to stamp it. We're going to go over this today as well and review some old sound concepts. The bottom of this tells you to draw air. That's a very difficult thing to do since air doesn't really look like anything. So can anyone give me an idea of how I can draw air? Any thoughts? Thomas? Air molecules, the particles in air. So when I ask you to draw air, you're going to draw a bunch of dots. But I want your air at sea level to look different from your air at 5 kilometers. So at sea level, Adele drew her air particles really close together. Above sea level, it gets thinner, less dense. And in fact, Sin wrote her kind of pattern that she noticed was the lower you are in terms of sea level, the closer to sea level you are, the higher the density, and the higher the altitude or the greater your height is, the lower the density. This is an inverse proportion. As the density and pressure increase as the altitude decreases. So they kind of are inverse proportions. So height is inversely proportional to density and inversely proportional to pressure, meaning that height is proportional to the fraction or the reciprocal of density, the reciprocal of pressure. So we've got high density particles here, low density particles here. We've established that there's an inverse relationship between altitude and density and pressure. Any other patterns that some groups have noticed? I want some new groups here. So group 7, group 1, this group up in the front or in the back. Can anyone contribute anything else? Alec. Temperature is pretty proportional to sound speed, right? If you look at this pattern, and I'm going to move this down a little bit, as your temperature changes, your sound follows it pretty closely at a higher value, but they're basically aligned. But we've kind of got this weird fluctuation, kind of like it's going in and out and back in again. And it's kind of odd where right here, the temperature seems to get significantly higher for some reason in this area. So what we know is temperature for sure is aligned with speed of sound. There's a clear correlation between the two. And right below in our atmosphere where people inhabit, we've got a pretty distinct relationship between pressure and density decreasing as you get higher above the ground, and even temperature and speed of sound decreasing. So we say that the speed of sound is 343. That's an average temperature value. But if I were to go higher up into the mountains, maybe the top of Mount Everest, the speed of sound is actually going to be slower than 343 meters per second.